So in this linked list, at position 3, we want to insert 7. But looks like it has insert 0, 1, 2, 3. In this position, it has inserted 7 but has lost these elements. Let's figure out where the error could be, and looks like I have got it here. It should be next. Then run again. Run this code again. And then this code again. Yes. So at position 3, 0, 1, 2, 3, we have inserted 7 using this function. And again, this function is not within the class. So far, we have covered how to create a node class, how to create a linked list class, how to insert a node or a value at a specific position or in the head or in the tail of a linked list, and then how we can display the linked list. Now we will see how we can delete a node from a linked list. To delete a node, we need to know which one is the previous node of the node which we want to delete, and then we will find the index position, okay, which index we want to delete, and then we will just assign previous nodes next to current nodes. What we will do is we will assign previous current nodes next to previous nodes next. This equation or this condition will delete a node. Okay, so and we will define this method inside the class. Let's define, and we will name the class erase. Erase, we must have to have self parameter and idx is equal none. So the user will give an index of and because he or she wants to delete that index's value or that node. Okay, totally. We first initialize index to 0 and then initialize current node as our self head node, and then for first time our also we need to have our previous node information, right, as I told earlier. So we will initialize previous node as none. Okay, if it's first node, then the case would be different because we'll have to update the head information in that case. Okay, and the time complexity would be O1 because it's just the head node, right? If idx equal index, which means if idx equal index means our given idx is 0, which is head node, and you just update head node to the current nodes next. I mean, you can also do it like self.head is equal to self.head.next, but for coding clarity, what we have done is we have assigned current nodes next as our head, and you can return from here since you are done. But if it's not a head node, delete a node at a specific index. Okay, the time complexity of this one would be O(n) because we'll have to traverse to that position. So what we will do, while current node, which means while current node is not equal to none, okay, while current node is true, if idx is equal to index, which means if we get our desired position, we will go for all the deleting thing, and the condition is just assign previous dot next is equal current node dot next. I'll explain that in a bit, and then return from here. You're done. But if your condition didn't meet, then you have to progress the while loop. How? We'll just assign previous node is equal as your current node, and then you will change current node as current nodes next. Okay, I'm sorry, this one would be else. This one would be under else, because if you did not return to your calling place, you will progress your while. Otherwise, no need to progress your while loop, right, every time. And then index would be index plus 1. So see, if your index matches, you will delete the node with this. This is the deleting syntax, right? Because if your previous nodes, just your previous nodes next points to your current nodes next. So the current node information, which is current nodes information, will be gone from middle. So now let's see whether our erase works for us. So let's see. So we want to delete ll.erase. Suppose we want to delete 3, the information that we have in 3, and then again display. Let's see how that works. ll.erase. Okay, does it have what happened? Linked list has no attribute erase, which means we somehow did not, it's not counting. Okay, yeah, we have not run this actually. And then if you run this one again, so at index number 3 we inserted 7, remember, here, and now we are deleting it from here. So we got our this list back. So here's our erase definition. With if it's head, then it's O1, and if it's in a specific location, or it might be the tail, right? It might, for tail we don't need any special syntax or special coding. So let's see whether we can delete the tail 0, 1, 2, 3, 4, 5, 6. So our tail has an index of 6. Let's erase ll dot erase 6. Run. Yes, it has erased the tail one, so it doesn't need any special condition or special coding for erasing the tail. It's within this code snippet. It's deleting tail. Okay. Now just remember, if it's head node, then you just need one condition for deleting the head node. And also if it's a index node, specific index node, this condition is enough to delete the object. Just previous.next will be assigned current nodes next, and the current nodes information will be gone. Okay. Our next function would be, or method would be, delete duplicate node from a sorted linked list. So we have to have a sorted linked list for this condition, right? So if we have a sorted linked list, then we will delete duplicate node from a sorted linked list. If you notice that our this linked list is already sorted, which means it's in ascending order. The next element is either equal or bigger than the previous element. Okay. If we want to delete duplicate items of a linked list with time complexity O(n), then just very easy. If a current node and next node's data are same, assign the current node's next pointer to our current node's next to next pointer, and that information will be gone. Like if this node's value and this node's value are same, then just this node's next pointer will point to this node. That's it, and the current node information will be deleted. And the time complexity is O(n) because we have to traverse to that position, so we don't know whether we need one move or n moves. N is the number of list in the element. And again, we will define this method within the class. Let's name it definition erase duplicate. The parameter would be just self, because we don't need any index information. We will just need the duplicate ones. We'll have to figure that out. Okay. Again, just first thing first, assign current node as the head node, and then okay, one thing is very important in this, that we have to check, like whether current node and current node's next node are not none. This is a very important thing. Like if we just say while current node and but we will be using this information too, so we need to know whether these two are not empty. Okay, so this information is quite important. Then I will say this is the main condition, that if current node dot data equal current node dot next dot data, which means if current node's data is equal to if if you see, look at here, if this data is equal to the next data, next node's data, then we will erase the next node's data. Okay, if current node's data is equal to current node's next node's data, current node dot next is equal current node dot next dot next. Okay, else just progress the loop, current node assign current node dot next. So just this is the main condition. You check this condition and delete the node, delete the duplicate node. This is the main condition. Okay, it's done and very simple and easy. Let's see, run this. If you have to run this cell because this cell has been updated, and now here come use it, ll dot, let me see the name, erase duplicate, ll dot erase duplicate, and then again ll dot display. Looks like there's an error. Let's figure out the error. So I think the problem is, see, when I compared current node dot data so I think the problem is that when I call this display function, I forgot to put those braces. Now let's see whether we can delete the duplicate nodes. Okay, run the whole thing. Yes, there you go. It has, from this list, it has deleted all the duplicate elements. So see, that's pretty simple. You have to just, sorry, I have duplicated this information. So just check whether current node and current node's next is not empty, and current node and next node's data are equal. If it's equal, then just delete the current node or just progress with your while loop. That's it. So we have seen that how we can delete duplicate node from a sorted linked list. This sorted is very important. Okay, we have to have a sorted list for the method we have developed. It must have to have a sorted list. Now we shall see how we can reverse a linked list. Okay, let's get started. So if we want to reverse a linked list with that time complexity O(n), normally for to reverse a linked list, the time complexity in a single linked list is O(n) because we have to traverse through all the elements. Suppose this is our list, 5 is pointing to 7, 7 is pointing to 9, and 9 is pointing to 3. So we'll have to convert the structure in a way that it reverses the list. Like 3 is pointing to 9, 9 will point to 7, 7 will point to 5. So you have 5 things to do. Store the next node in next, which means suppose 7 is our current node, so we have to reserve this list. Why? Because we have to go to the next one. So we will reserve this list using our current node to next. So our next would be our this node because it has the information of the rest of the list. So we have to reserve this in next. Assign previous to current nodes next. So these nodes next would be 5. So assign this node next to 5. Okay, and make current node with its new next previous. Okay, so now just see, remember we have stored it, store the list information in next. So we will go to the next node to 9 using that next one, and we will do this way the same thing. When we go to 9, we will assign its next node as 7. Okay, so our head node would be the last one. Let's see how we can code it.